Hello everyone. Hope you all are doing well. Today's topic is graph. We will discuss some interesting topics of graph and will try to understand in simpler manner. So without any further ado, let's begin. So what is graph? A graph is a collection of nodes called vertices and the connections between them called edges. A graph is non-linear data structure which is a set of points and set of links which connects nodes or vertices. A graph is composed of V set of vertices and E set of edges connecting the vertices as shown in the following diagram. So here we have A, B, C, D and E which all are vertices and all the lines which are connecting them are edges. Next, coming to some terminologies which we use in graph. Let's see the graph terminology. So while discussing about graph, you come across some words, some terminologies, okay? So let's see what they are. First is vertex, individual data element of graph. So here each node, let's say A, B and C are vertices or let's call them as nodes. Edge, it is connecting link between two nodes. It's just a link as we can see here. So these edges are of three types: undirected, directed and weighted edge. So what they are, let's see. So let's take example of these A, B and C graph. Here all vertices have undirected edge. It is also called as bidirectional edge. That means whatever direction you want to go, you can go. Let's say from A to B or B to A and so on. It's bidirectional. So second is directed edge. Here the direction is defined. We can go from A to B, but we can't go from B to A. And next is weighted edge. Age with cost on it. That means it will have values. If you want to go from C to A, then it weighs is 5. Next is mix graph, a graph with undirectional and directed edges. It is nothing but having both directed and undirected edges. The above graph is example of mixed graph. So coming to the next topic, graph representation. Basically there are two computer representations of graph. First is adjacency matrix and second is adjacency list. So the first one is adjacency matrix. In this representation, each graph of n nodes is represented by an n into n matrix A. That is a two-dimensional array A. The nodes are relabeled as 1, 2, 3 and till n numbers. So A of I and j is equals to 1. Let's discuss it further. Let's understand it with an example. Let's take int a 10 of 10, 10 into 10. It can be used to store a graph with 10 vertices. Okay, that means a of I and j is equals to 1 indicates presence of edge between two vertices I and j. Similarly, a of I and j is equals to 0 indicates that there is no edge present. So let's take example of this here. Here we have 0, 1, 2, 3 as vertices, and you can see a chart which is nothing but a two-dimensional array of the representation. So from 0 to 0 is 0 as there is no edge or link between it, so it is 0. From 0 to 1, yes, there is a link, so it is 1. From 0 to 2, yes, it has link, so it is 1, and so on. Since this is undirected graph, For edge 0 to 2, we also need to mark edge 2 to 0, making the adjacency matrix symmetric about the diagonal. Okay, so edge lookup, that is checking if an edge exists between every vertex, is extremely fast in between adjacency matrix representation, but we have to reserve space for every possible link between all vertices, so it requires more space. Yeah, so second one is adjacency list representation. A graph of n nodes is represented by one-dimensional array L of linked list, where L of I is linked list containing all the nodes adjacent from node I. The node in the list L of I are in no particular order. So let's try to understand with this example. Here we have different nodes which have particular values. We can call them, we have represented them as human names. So as we can see, it is directed graph. So L of 0 is empty as no link is made from L of 0. Similarly, L of 1 is also empty as well. Next, L of 2 has 4 links, that is from L of 2 to L of 0, L of 2 to L of 1, L of 2 to L of 4, and L of 2 to L of 5, and so on. In some examples, it is also represented as list depending on the connected links. An adjacency list is efficient in terms of storage because we only need to store the values of edges. For a graph with millions of vertices, this can mean a lot of save space. So yeah, that's it for today's topic. Thank you for watching the video till the end. Thank you once again, and we'll see you in next one.